We're the Healthineers, and we've decided to take on challenge 6, which is around looking at whether health and safety data can be used to reduce accidents in the workplace. So why is this important? So there's some big numbers in here. 6.3 million working days were lost last year, 0.7 million workers sustained non-fatal injuries, and £5.6 billion was lost to the economy. But the most poignant number on here, I think, is that last year, 111 people went to work and didn't come home to their families at the end of the day.
So as a manager, how can I identify the location, contract, and date with a higher probability of accident? When we analyze this data set, we realize that the overall probability of an accident happening is unknown and will be difficult to compute. But knowing that an accident happened, we can calculate the probability of it happening for a given contract, location, or date. So using this simple formula below, we are able to compute the probability of an accident happening for a given location, for example, which is the number of accidents at a given location divided by the total number of accidents. And using this idea, we were able with Python to load the raw data, clean the data, for example, removing the duplicated entry, compute the probability, export the file in Excel, and then John was able to load this file and integrate it in an interactive dashboard in Power BI, which could allow manager to identify category or combination of category that are more at risk of an accident happening.
And the way we did that was by generating probability models by using regression analysis. What our main aim was there to achieve an accident score for an event occurring. Our models can dynamically select the columns that are highly correlated with the accidents and the near misses. So in the future, when the columns change or the features are added or reduced, no manual work will have to be done. The columns will be selected dynamically. Then we also identified which features contribute to the greatest towards the probability of an accident occurring. And you can see an example of a chart at the right side. Then in order for us to visualize that, we had to aggregate the incidents by month. So that gave us an idea of how many accidents were happening each month, year on year. And then finally, we created a regression model with an accuracy of 73.4% that gave us an idea of the accident happening.
So based upon the data modeling, we produced a suite of dashboards, the first two being executive summary dashboard. So here we're presenting KPIs of the data, as well as drilling into the number of incidents and breaking it down by features such as location, activity, contract, etc. What we noticed is that the number of incidents is quite cyclical, so it repeats itself throughout time, and we see spikes in the data at certain times of year, usually towards the end. We also noticed that there was a number of that we were reporting more accidents than near misses, which surprised us. So we suppose that there's probably a reporting issue there and we're not reporting enough near misses. We then generated an incident profiling tool, which allows someone to drill into the data, which is specific to them, break it down by what they're interested in, so location, contract, and follow the flow through the whole the suite of data. And then presenting the probability models that were built, we did two dashboards, one which allows us to present a combination of features and also presents the most likely incidents that are going to occur, and then a second dashboard that also presents a more static KPI feature with the probability, so breaking down by individual features of the data. And to both of these dashboards we assign drag status, so it is immediately identifiable what's high risk and what's acceptable risk. On to the questions.
The first question was, is there enough data to reach statistically robust conclusion? The first issue is that with the quantity of observation, especially after cleaning, the number of data was insufficient given the number of variables. There were some issues about quality of data, some interesting things were missing, such as accident category, time and debt, contract start date. Scope of this analysis could be to include health and data, work-related illness, which could be useful for health and safety to expand the scope of this data set.
And then the final question was, how can this be utilized by someone in management, for example? So just to demonstrate the interactivity on the probability dashboard, that is the combination of features, for example. We have it fully interactive here. So initially you're presented with the activities as they are the most probable to occur. And then from that, we are able to drill down into combinations of features that are of specific interest to us. So this feature could be used by a manager at a toolbox talk. So you could find out specifically what's occurring in the month, and then you see which activities are going to be most likely to cause an incident. And again, this is going to automatically generate a RAG status.
So I think we can conclude by saying that a lot of actionable insights can be done using the predictive model we've got, using the features of the location, contract, the activities, and certain trends. And the model will self-learn based on the features that are coming up on the data. And this will really help predictive analytics of areas where the HSE managers need to put in their most attention for reducing health and safety incidents. Thank you.